What would actually happen if all the ice on Earth melted completely? It sounds like pure science fiction, but something remarkably similar already happened before. Thousands of years ago, melting ice already reshaped the entire map of our planet. This isn't just a hypothetical future. It's real, documented planetary history. So let's look at the real science. What melts, what doesn't, and what history already proved. Some of what you assume about melting ice might actually surprise you. Let's start with the ice itself, because not all of it behaves the same way. At the North Pole, the Arctic is mostly frozen ocean water, floating sea ice. At the South Pole, Antarctica is an entire frozen continent, sitting on solid land. That single difference changes everything about how melting ice affects sea levels. Here's the surprising part. If all the floating sea ice at the North Pole melted, sea level wouldn't rise at all. That's because floating ice already displaces exactly the same volume of water it would become. It's the same principle as ice cubes melting in a completely full glass of water. Land-based ice is a completely different story. That's where the real danger actually lives. Antarctica and Greenland hold almost all of the land-based ice on Earth. When that ice melts, the water has nowhere to go but directly into the ocean. So how much would sea levels actually rise if every bit of that land ice melted completely? According to NASA and the U.S. Geological Survey, the answer is roughly 65 to 70 meters. That's over 200 feet, enough to submerge nearly every major coastal city on Earth. Antarctica alone accounts for about 58 meters of that total potential rise. Greenland contributes roughly 7 more meters, with mountain glaciers adding a small amount extra. To be clear, scientists don't expect this full amount to happen quickly or even soon. This total number represents an extreme, long-term theoretical maximum, not a current prediction. But understanding this number helps explain exactly why scientists study melting ice so closely. Here's where real history becomes genuinely important. This isn't the first time Earth has warmed. About 125,000 years ago, Earth's temperature was close to today's levels. Scientists call this the last interglacial period, a warm stretch between two ice ages. Back then, sea levels were measurably higher, roughly 4 to 6 meters above today's levels. That rise came from partial melting of Greenland and West Antarctica, the same regions scientists watch today. Earth has genuinely been here before, in a warmer world with noticeably higher seas. That's not speculation. It's measured directly from ancient coral reefs, fossil shorelines, and ice cores. History leaves behind its own careful record, if you know exactly where to look for it. An even more dramatic chapter came later, as the last true ice age finally ended. Around 20,000 years ago, enormous ice sheets covered much of North America and Europe. As temperatures rose, those massive ice sheets began melting, pouring water into the oceans. Over the following thousands of years, global sea level rose by an astonishing 130 meters. That single change completely redrew the map of the entire world. Doggerland, a stretch of land connecting Britain to mainland Europe, disappeared beneath the waves. The Beringia land bridge, once used to migrate into the Americas, was swallowed by the sea too. Entire regions where prehistoric humans once lived and traveled simply vanished underwater forever. This wasn't gradual and gentle the entire time. Some of it happened astonishingly fast. Around 14,600 years ago, something remarkable happened, called Meltwater Pulse 1A. In roughly 300 to 500 years, global sea level rose somewhere between 14 and 20 meters. That's a genuinely staggering rate, many times faster than anything happening on Earth today. Researchers believe the meltwater came primarily from collapsing ice sheets across North America and Scandinavia. Entire coastlines that prehistoric communities knew as home shifted dramatically within a few human lifetimes. Some researchers have even wondered whether this dramatic event helped inspire ancient flood legends. Many cultures across the ancient world tell strikingly similar stories about a great, world-changing flood. That connection remains a hypothesis, not a settled fact, but it's a genuinely compelling one. Either way, the physical evidence for this rapid ancient flooding event is extremely well documented. Coral reefs around Tahiti and Barbados still carry the physical scars of that ancient event today. So how does today's situation actually compare to these dramatic ancient events? Satellites have directly measured Greenland and Antarctica's ice sheets, losing mass since around the year 2000. Right now, global sea level is rising at roughly 3 to 4 centimeters per decade. Compare that to Meltwater Pulse 1A's pace, roughly 3 to 4 meters per century. Today's rise is far slower, but it is measurably accelerating, according to satellite records. Current projections from the Intergovernmental Panel on Climate Change estimate a rise of roughly 0.3 to 1 meter by 2100. That's a small fraction of the full 65-meter theoretical maximum, but still significant for coastal regions. One region concerns scientists more than most: the West Antarctic Ice Sheet. Much of it rests on bedrock that sits below sea level, making it especially unstable. If it collapsed rapidly, it alone could add several meters of sea level rise within a shorter time frame. So what does all of this really tell us? Earth's ice has changed dramatically before. Entire coastlines have vanished before, reshaping where humans could live and travel. What's different today is the cause. This current warming trend is being driven by human activity. That's a genuinely important distinction between today's changes and the natural cycles of the deep past. The physics connecting melting ice to rising seas, though, remains exactly the same as it always was. That's exactly why studying ancient sea level history helps scientists understand today's changes. The past becomes a genuine scientific tool for understanding what the future might actually hold. Full melt, the 65-meter scenario, remains a distant, long-term possibility, not tomorrow's headline. But even smaller, more immediate changes still carry real consequences for coastal regions worldwide. It's worth understanding just how old some of this ice actually is. Some ice in Antarctica may be nearly 1 million years old, trapping tiny bubbles of ancient air. Scientists study those ancient air bubbles to understand exactly what Earth's atmosphere looked like long ago. That makes glaciers something like a natural time capsule, quietly recording Earth's climate history. Losing that ice doesn't just raise sea levels, it also erases an irreplaceable historical record. That's part of why scientists study these ice sheets with such genuine urgency today. It's also worth remembering that sea level rise doesn't happen evenly across the entire planet. Some coastal regions will see faster, more dramatic changes than others, based on local geography. Ironically, areas closest to melting ice sheets can sometimes see smaller local sea level increases. That's due to changes in gravity, as massive ice sheets actually pull nearby ocean water toward them. As that ice shrinks, its gravitational pull weakens, and that nearby water spreads elsewhere instead. That's a genuinely surprising detail most people never consider when picturing melting ice. Science here is rarely as simple as water, just rising evenly everywhere at once. That complexity is exactly why researchers rely on satellites, ice cores, and ancient coastlines together. Each source fills in gaps the others simply can't cover alone. Earth's story has always included ice, water, and dramatic, world-reshaping change. We happen to be living through one small, closely watched chapter of that very long story. Understanding the deep past doesn't have to be frightening. It can simply be genuinely clarifying. Real evidence, not speculation, is what actually tells us how this story has unfolded before. So would every coastal city eventually vanish underwater? Only under an extreme, long-term scenario. What do you think the next chapter of this very long planetary story will look like? If this deep dive into Earth's icy history interested you, subscribe for more real science from the past. The ice has told this story before. Now science is finally learning how to read it clearly.